Hello and welcome. This is the day 6 stream of my work on the Gunship game engine. Yesterday, when we left off, I was in the middle of debugging a pretty nasty bug. Let me pull that up right now. So yesterday we were working on getting communication between the resource loading code and the basically the renderer. Specifically, when we load stuff like a mesh or a material, it comes in as a text file. We can parse it into more structured data, but ultimately that data has to go to the engine or to the renderer. Specifically for meshes we call renderer.registerMesh, and for materials we have to call renderer.buildMaterial and then renderer.registerMaterial. And in order to make that safe to do concurrently, we can't do that in parallel. The renderer is currently not well equipped to be accessed in parallel or to do anything in parallel. So we do have to synchronize access to the renderer, which includes synchronizing resource creation. And to avoid having to throw a mutex around the renderer and have all of our resource loading threads basically synchronize around that, which would slow things down a bunch, we've instead opted to send it through a channel across threads. So each of the worker threads has a sender channel, which it can then use to send a resource message to the renderer. And then within the engine's main loop, which we have defined right here, each frame right before drawing, it will process any pending resources and make sure that all resources are set up so that when it goes to draw, it's not going to try to like draw a texture that hasn't been loaded yet, that sort of thing. The problem that I was running into yesterday was when loading a material, this call to send render message would fail. Specifically within send render message, calling send on the channel would segfault. And what I was doing yesterday was I was stepping through the disassembly, and what I found was it wasn't like a null pointer dereference or anything like that. It was specifically, it would enter the function, I could step through the disassembly, and then when it got to the end point of the function, instead of returning back up to send render message, it would jump into random memory and get an access violation. And so I spent a while debugging that yesterday on the stream. I didn't quite figure out what was going on. I continued to look into it afterwards. And I made a post on the Rust user forums asking if anybody could advise. So I posted an example of the code, posted what I was finding was happening at the disassembly. I thought it had to be something weird with CodeGen because it just seems so crazy to me that it would return to some invalid point in memory that it just seemed like the disassembly was doing something wrong. And one of the users online pointed out, hey, you're doing something weird with this whole uninitialized memory within an unsafe cell. You could achieve the same thing with ref cell option and it would be safe. And I was like, that doesn't seem like that's going to fix the problem, but let me at least try it just to rule it out. And I did it, and sure enough, what happened was when I tried to load the material, instead of this segfaulting, this panicked. When I went to unwrap the option, it was none, which means this had been failing because it was uninitialized. And what I realized when I took a look at it was when I spawned each of my worker threads, each of the threads has a thread local sender. And for each of the workers threads that I spawned, I set up this channel. But on the main thread, the one that's doing the spawning, I forgot to set up the channel. So I added one more in here where we also set up the channel for the main thread. Now it works. So the moral of the story is don't try to optimize your code with uninitialized and unsafe stuff before you've actually found out where the problems are. I should have. I mean, part of this wasn't just like I was trying to optimize it. It was partially me thinking like, oh, I just need to set this up once. It doesn't need an option. It doesn't need a ref cell. That's silly. It's just like, just set it up once and then it'll work. But for now, ref cell option is the smarter way of going about it, even if it seems like a bit of overhead, because any mistakes I make get caught, they get checked at runtime, and once I find that this is not going to work, I can easily return to the pattern with where it's just like sender, and I just use some unsafe code to initialize it once at startup, and I'll get all the speed back, but I'll already have debugged any problems I would have run into. So yeah, I think I still too frequently jump to, oh, I got to do unsafe to get the effect that I want, and I got to kind of get out of that mindset when I'm doing Rust development. But that's fine. That issue has been resolved, and if we run the code as it currently stands, we'll see that it pops open almost immediately. And if we take a look at the debug output, we'll see we start loading the material, start loading the mesh. The material ends, and then sent material to the GPU actually occurs within the engine loop, which is happening down here. So that means that at that point we have already finished registering the engine has received the material source and has registered it with the renderer. And then after that happens sometime later, we finish loading the mesh, and then the renderer. Then let's see, the example code actually receives the result. That's here, received the mesh. And then sometime after that, the engine loop sends that material to the GPU. So this actually highlights an interesting question. That with this async resource loading, there's the potential to have the game attempt to render using a resource that hasn't been fully initialized with the renderer. For example, let's say that with an experiment, so now this is what we've got going on. This is like one of the next things that we're going to work on. After we finished loading the resources, we're going to want to create something in the scene with them. For example, I'm going to want to create an object in the scene, a transform in the scene, and then render that mesh at that point. And as we've seen, this code returns and starts running before the mesh actually makes it to the GPU, before it starts running, before it's registered with the renderer. So it's possible that this code is going to get run and going to complete running before the engine is ready to load the GPU, or before the engine has received the new mesh and has sent it to the GPU. And if that happens, the engine might potentially try to render the scene that has, say, this mesh in it, but the renderer might not have received that mesh yet, and that's going to cause confusion at best if the mesh is just invisible or just doesn't get rendered at all, and at worst it's going to crash. Actually, I'd say that's the other way around. At best it'll crash, and at worst it'll just silently do the wrong thing, which I am not a fan of. So in theory, even if this returns before, or even if this is run before the engine has processed that mesh and sent it to the renderer, it should have already been queued up for the engine to see by the time this code is executing. So in theory, if this code were to just super quickly, before the engine has a chance to pull it out of the render queue, if this code were to set up that mesh in the scene such that the next time the engine tries to draw, it will use this. In theory, the engine will have by then, or it'll have to go through this path and we'll have sent the mesh to the GPU so that when it gets to draw the scene that has the mesh in it, it'll already be processed. I don't think we can count on that though, because let's look at the case here. Somehow, let's say the edge case happens where the new mesh is sent into the render message channel, but it happens just after the engine is like finished. It thinks it's finished pulling out all the render messages for the frame, and now it's about to go into draw. And somehow this new stuff within the scene gets set up in between that time. And so now the engine attempts to draw the scene that has the mesh in it, but it hasn't gotten back around to pulling out the pending mesh that still has to be processed before it can draw. It seems like a little bit of a far-fetched case, but this is multi-threaded code. Like perhaps perhaps the engine goes through everything that's in the queue currently, and then before it draws, the system sleeps this OS, it suspends it, or it suspends this thread, runs like some other process's thread, and then while this one continues to run, this one sets up the scene so that it can render the mesh, and then by the time this one resumes, it's now about to draw, but now the scene has a mesh in it that hasn't been sent to the renderer. So the renderer is not going to know about that mesh. Is going to be undefined behavior. So it seems to me that we need some kind of synchronization surrounding resource loading, the way that the scene is set up, synchronization between, game code doing some amount of work for a frame versus the engine main loop having to wait until it's been rendered, or wait until everything's been set up before it attempts to render. Because currently, the way that I'm setting up the engine main loop is with this run macro, which basically means, in theory, or conceptually, it's kind of like spawn a worker thread, run this code on that worker thread. And since this is just a loop, there's no real synchronization going on in here. So this is just like it never yields, so it just sits on that thread forever, and it's just running a loop, and it just goes for forever. So this main loop currently is completely unsynchronized from anything else that's going on. If we notice here, other stuff going on in the engine uses a wait. So this main scene doesn't keep running after it starts to load the mesh and load the material. It suspends itself while the mesh and material are loading, and then on that same thread some other work could be done. It seems to me we want to do something similar with engine, where this does like await all the game code needs to finish. And this should probably actually be more like up here. Like that's basically what the update is like somehow let the game code know that do a frame's worth of stuff, do it all in parallel across as many threads, across as many cores as you can, and then once it's done, we'll do the little bit of work that needs to be done in serial, that can't be multi-threaded currently, which is the rendering work. But somehow we need to be able to say at the top of the frame, make sure there's nothing still on the fly that's going to potentially disrupt rendering or disrupt any of this other process. I don't know currently how to implement that though. Let me stop and think for a second. I need to stop and collect my thoughts, because I'm going through this and I'm talking about, hey, this is a big problem, but I don't necessarily know what the solution is at this point. And if I just kind of ramble on about this problem, I don't know if I'm going to necessarily make progress. Because there are other issues to be dealt with currently. And those may be more pertinent issues to deal with. And so perhaps I will start there just to see what it's going to... Let's take a look at some of the other stuff that's pending, because we've got a whole slew of issues to deal with, things that need to be, that are still, half implemented, or have edge cases that haven't been addressed, or just haven't even been started on. So if I don't have a solution to this whole synchronizing the update loop yet, I can perhaps work on something else while I ruminate on it, and then eventually I'll come back to it and have a good solution. The update. So one of the things that's still left to do is we haven't cached off any of this data. There's no resource manager. Create an association between mesh ID and GPU mesh. Now, in terms of caching off resources so that you don't try to reload the same resource more than once, that's an optimization. I honestly don't care about that a ton right this second. I can probably just, if I could just not do that now, and so every time you try to load a resource, have it completely reload the resource in just a completely unreasonably inefficient fashion, and then transparently add it in so that if you request a resource that's already been loaded, it just uses the previously loaded resource. That wouldn't have any impact on the API, so I'm not really worried about it. What I'm talking about, to be clear, is, so let's see right now, I'm loading a mesh. I do load mesh, examples, meshes, gunsmall.dae. I don't know why I'm using this one. Probably want cube.dae. So let's do resource load mesh, examples, meshes, cube.dae. And then let's say I were to do it again. I were to, at some point, let's say, just for example, we're going to do it here, but in reality it would be someplace else. Let other mesh equal await load a different mesh. This is now going to run it's going to do the exact same thing that this was. This is going to load the mesh, process it, send it to the GPU, and this is going to just open that file up again, read in all the text, process the text, send it to the GPU again. So now on the GPU there are going to be two meshes that have the exact same data in it. GPU doesn't care, renderer doesn't care. If you tell it there's multiple meshes with the exact same data, it's just going to go along with it. Oops, I gotta comment this code out. Actually, I want to run this just to see what happens, just to make sure there's not some weird edge case, like a weird bug that I've already put in there. There we go. So now we can see, start load mesh. After we finish the mesh, then we do another one, sent mesh for 2 to the GPU. Start load material, start load mesh, end load material, done load mesh, start load mesh. Okay, so here's, what the heck? This is a bug. Oh no, it's not. I'm just dumb. Okay, so what I thought was happening was, or is it? Start load material, end load material, start load mesh, done load mesh, start load mesh. Okay, yeah. So what I thought was happening was I thought that this mesh load was finishing before this material load was. Once this mesh load finished, this would return, get to here before this load material is done. So basically I thought await was broken, and I was just misreading the output, so I do not believe that was the case. But so yeah, so when we try to load this these two meshes multiple times, it works just fine. It's completely inefficient because every time we try to ask for the same resource, we're going to load a copy of it into memory. But I don't particularly care about that because we're not really doing much of anything currently. And what I could do is I can just transparently make it so that a request to load the same mesh just uses the cached mesh now and doesn't do any actual loading. And that wouldn't change the API at all. I could leave the exact same code and it would just suddenly become faster. What I do care about is how we're going to specify what mesh to use when rendering. So for example, when I do this, when I try to create a mesh render and I pass in the mesh that's returned by load mesh, this is currently doing, this mesh is an ID. And we can take a look at the ID that's generated in load mesh. So load mesh returns this mesh which wraps mesh ID. Mesh ID is just determined by mesh ID counter, which is just a use size that gets incremented each time we load a mesh. However, currently we don't have anything that associates that mesh ID with the actual identifier used by the renderer. So within the engine, we've got this mesh ID, which is just like this opaque identifier type that is used to reference mesh data that was loaded. And the renderer does the same thing. The renderer has got when you send it mesh data, it internally keeps like a backend specific cache of data. So for OpenGL, it has something inside of it that's tracking vertex buffers and index buffer IDs, and it's keeping track of that internally, and externally it returns a backend non-specific identifier. So in theory, if I were to swap my backend out from OpenGL to Vulkan or Direct3D or Metal or whatever, GPU mesh stays the same. Inside the render, it can do whatever it needs. It's platform specific because it's returning a non-platform specific value. But when we specify to this mesh renderer that I want to create, I'm not specifying the GPU mesh, the ID that the renderer is using. I'm specifying the ID that the engine is using. I'm specifying this mesh ID, and so as it stands, once I create that mesh renderer, it's going to get that mesh ID, and then when we go to try to render, it's not going to know what to do with that mesh ID. We're gonna give it this mesh ID, and then it's gonna say, okay, now what GPU mesh should I be using? And there's no way to find that out currently because we don't do anything with that information. So that is potentially the next thing to work on, is to create some kind of centralized map that says if the game is trying to use this mesh ID, then that means ask the renderer to use this GPU mesh. And I think that's a pretty reasonable next step to work on. So why don't we start with that? So that also gives us a little bit of a buffer before we can think about the sticky issue of how do we deal with the update loop in a fully parallel game engine. All right. So I think at the very least, what we're going to want this to do, or what we're going to want this to be, is a map. I'm going to throw it in the engine right now. I'm going the wrong way. I meant to go down here. I'm going to throw it in the engine right now. I don't feel like that is the right place for it, but at the same time, I don't care. It just honestly doesn't matter a ton. It doesn't really matter a ton where it's going to live, and the engine's the kind of our central rendezvous point for doing stuff. So, especially for anything that needs to be, not done in parallel related to the renderer. So I'm going to be able to live with that. So what we're going to do is we're going to do a mesh map. It's going to be a hash map that maps between mesh ID and GPU mesh, I believe is what the types are. And we got to do the same thing with materials. Although I'm going to start with meshes just to figure it out, and then I'll probably implement materials later because there's a lot of complication here, and I probably want to go through it all with mesh once, and then see about adding support for materials. The only reason why I even started off loading the material in the example is just so that I could test out I could have multiple resources to load in parallel. And I guess in theory I could have just done that with multiple meshes. I could do a test scene with like 5 meshes in it and just load multiple meshes. Maybe if I were smart I would think about that first, but I'm not. So we're doing it this way. So assuming that we've got some kind of map between the mesh ID and the GPU mesh, this should be just as simple as engine.meshmap.insert mesh ID GPU mesh, and then this should be let last equal assert last is none. Duplicate mesh ID found. Mesh ID. So what's going on here is hashmap.insert will override the previous value that was in there. So let's say I'm trying to insert a key 7. If there was already something in that map where the key was 7, hashmap will just plop the new value into that bucket, and it will return what the old one is. It returns an option that either is none or has the old value that was that had the same key. Now, mesh IDs are meant to be unique. You should never generate the same mesh ID twice. So if this ever happens, we want to assert, because that means I did something wrong somehow, or I'm at least assuming that the same mesh ID will never come up. I may be wrong about that. It may be completely reasonable for the same mesh ID to come up more than once. But if that does happen, we're not handling that at all. Currently, we have no way to have multiple different meshes with the same mesh ID within the mesh map. So that's just going to break things entirely. So if that does happen, I want to assert on it and just make sure that it works. And note that, so I could alternately have done this. I could do assert engine.mesh map.contains key mesh ID. To do assert not contains key mesh ID. But this calling like contains key involves a hash lookup, and then insert involves another hash lookup. Whereas if I just do insert and then check the value that it returns, that only does one hash lookup. So this is it's strictly faster, and it's not unsafe this time at least. So no chances that that'll be all terrible the way that it was last time. So mesh map between mesh ID, GPU mesh. Let's update our engine initialization to make sure that this mesh map, hash map, new, And we're not doing anything with that, but we're not doing anything with that currently. But once that is set up, I can start working on this stuff, creating transforms within the scene and creating a mesh renderer that allows us to place in the scene, which will at least get me to the point of, then I can add in a camera and start rendering it, and that opens up a bunch of other stuff that I can work on. So that would be what I want to get working currently. So let's compile that, see what I'm missing. Missing hash map, missing mesh ID, missing GPU mesh. Kind of what I expected. So I'm going to do use standard collections hash map. And we also need mesh ID is within resource render resource message, and we also want mesh ID, and we also want, so we got polygon renderer, we also want GPU mesh currently. Mesh ID is private. That is completely fair and reasonable, and I hate you. I'm gonna do pub crate mesh ID for now. The type of this value must be known in this context. Last dot is none. Well, let's see if making the mesh ID public will solve that problem. Pub restricted syntax is experimental. I do so love using unstable functionality, but I've also been bitten by it before. Yeah, I'm gonna not bother with it right now. Failed to resolve use of undeclared type or module transform. Oh, duh. Just gotta leave the stuff commented out. Cool. So now the engine internally has a cache, or has a map between the mesh ID and the GPU mesh. And so then the next thing to do will probably be to try to create transforms and just see what it takes to get a transform set up, see what it takes to get a mesh renderer set up, and then a camera set up, and see if that can render. I'm going to take a quick break, and then we will get right back to it. Okay. So, next fun thing to start working on, we've got to reintroduce transform. I am excited about that because I have no idea how to do this reasonably in parallel. So let's close down our resource module. Let's close down engine for now. Let's start with just little old mesh transform. Transform, huh? So transform is effective. The transforms are the nodes in our scene graph. They specify position in 3D space, and they can also have parent-child relationships, where a child transform is positioned relative to its parent. And then anything that needs to be given position data is associated with a specific transform, such as the camera or a mesh renderer are each associated with their specific transform, so that they can be given a position and any other dimensions in 3D space that they need to be. This proposes a number of challenges. And I think I'm just going to have to dive in to start thinking about it. I'm going to start sweating about this. Ooh, this is going to probably get complicated. I'm just going to have to kind of start really simple and dumb and iterate on it as much as I can. So let's start by adding a transform module. QRS pub mod transform. And we'll see what we can get out of it. And let's take a look for reference what my old single-threaded transforms looked like. Probably not anything reassuring. We'll take a look. Oh boy. Oh boy. So transform. We got entity, we got parent, we got children, we got the actual data, and we got messages. We can basically ignore this. Parent, children, data is what we care about. And particularly transform data has the actual position, rotation scale for all of this. Now you might be wondering, as I am kind of wondering to myself, why do it this way? Why have this pointer to transform data? That seems weird. Weren't we just talking about how doing weird things with unsafe code is a terrible idea for terrible people? The answer is yes, you're absolutely right. The answer is the scene graph is also very much something that needs to be optimized. It kind of is one of the center points of the engine. Very much a workhorse and does a lot of stuff. Generally, you can expect it to be doing a lot of work every frame as things move around. Just if there's motion in your game, which they're almost, I can't really imagine a game that has no motion at all. There's probably going to be a number of changes, and especially if you have stuff like skeletal animations, like a skinned animation pipeline. There's deeply nested segments of your scene graph where these skeletal animations are happening, and so it's going to be doing a lot of work frame by frame, and it's got to do it fast, and it's got to be highly optimized. And so this was me beginning to explore an implementation that was used by the Ogre game engine. We take a look at ogre3d.org. I haven't checked this out in forever. Ooh, ooh, they redid their website. Now it's pretty. Maybe Ogre 2 has become stable? What version to choose? Ooh, Ogre 2.1. So this is important. So when I first started working on Gunship, I started on it in C++, and I wasn't going nearly as low level as I am going in Rust. I started with SDL to do windowing and like cross-platform support, and I started with Ogre as my 3D rendering engine. While I was working with Ogre, they were kind of in the midst of beginning the transition from version 1.x to version 2.x. And the 2.1 version was kind of like 2.1, I think around that time was mostly stable. But 2.1 is where the really good stuff was happening, where they had done a ton of optimizations. There were a bunch of posts online describing like the kind of work, proposals for how to make the engine faster, talks at conferences about what was going on. I believe Mike Acton, data oriented. Yes, Mike Acton of some game company. Mike Acton, who works somewhere. Yeah, works at Insomniac Games. He gave this talk about data-oriented design, and he actually, in this talk, uses Ogre as an example. It talks about the pre-2.1 version of Ogre, and just points out a bunch of places where it does a bunch of really inefficient stuff. And so part of the 2.0/2.1 push for Ogre was making the engine a lot faster, and there's a document that I had looked at a while back that describes what they did to get the scene graph to be very efficient, like cache friendly, data oriented. And I was trying to learn from that and take some of that into effect. And part of that is splitting the transform data into kind of a separate thing from the actual transform structure, and putting it in just these big arrays of data where each depth in the hierarchy is its own thing, and then you can just iterate over all the ones in a certain depth and go over all the depths. And it's a whole big thing that I'll probably wind up having to re-implement on the stream, because I don't know if I ever quite implemented it properly here. I'm thinking about it. I never really implemented it properly. I don't know if I got much out of doing it this way. I might have partially done it this way to get around the ownership issues that I was having with the entity with doing the ECS. I don't know. I'm thinking I'm gonna start with the non-clever optimized version, because I've kind of been burned by trying to start with clever solutions that I don't fully understand yet. I'm gonna go with the dumb non-optimized version, and we'll try to come up with a reasonable API that won't get broken when I pull out the guts of the transform and build a more optimized version. So let's start with pub struct transform, and we're going to keep this really simple. Parent, all right, we're already off to a good start, because we can't have parent-child relationships. Yeah, this is okay. This is simply getting transforms in, even in a very basic state, is gonna, I think, require a little bit of thought. So I kind of wish I had a blackboard. Like, I kind of wish I had something to write on, because diagramming some of this out might be helpful. I'm going to do my best to just talk through it. So, high level, talking about transforms. Transforms have specific things. that we need to be concerned about. Specifically, all of these things. And we're going to just ignore these. So, I'm gonna drop all of these in here, and then we're gonna talk about why just doing it this way is not gonna be smart. And we're gonna, instead of blackboarding, I'm just gonna write with pseudocode because that is about the best I can do. So, I'm gonna take a drink of water. My tongue tastes kind of gross because I just woke up. So, transforms. Transforms define a graph. A graph of nodes in the scene, each having their own position, rotation, and scale. However, they don't just have one position, rotation, and scale. They have two. Each node in the scene graph has a local position, rotation, and scale relative to its parent, but they also have a derived position, rotation, and scale, which are relative to world coordinates. So, for example, let's say we have a parent at 1010 and its child. Will that look right? Sure, close enough. Child is at local 3, 5. And we're doing this in 2D coordinates because I'm lazy. The global coordinates are going to be 13, 15. Because it is, the local positions are offset relative to its parents. And the same applies to scale, rotation, and scale. So if the parent is rotated slightly, and then there's a child node that's got a little bit of rotation of its own, it's going to be rotated slightly relative to the parent. Oh, uh-oh, my alarm's going off. Yeah, I got another 15 minutes or so to stream, so I'm going to see how much of this I can reason about now, and then I'm going to probably continue ruminating on it for the rest of the day, and then maybe by the time I come back to streaming next, be it tomorrow or another day, I'll actually have some place I can start with this. But this is a big problem that I don't want to just dive into, because otherwise I'm going to be slapping at the keyboard, spitting out garbage that's not going to be even remotely useful. This is a situation where putting some forethought in rather than just going with the absolute dead simplest solution is going to probably yield me some benefits. So we've got this parent-child relationship, and this parent-child relationship holds for all three of the coordinate types. Position, rotation, scale. So each node in the transform could just be like this. We could just have it, it holds its parents, holds its children, that's a whole nother issue I don't even want to begin to think about. And then it's got its local position, local rotation, local scale. The problem with that is rendering doesn't really care about local coordinates. Rendering only cares about global coordinates. As far as the render is concerned, the entire scene, the entire game world is just basically a big bag of meshes, each positioned at some point in 3D space. The whole concept of, parent-child relationships doesn't matter to the renderer. It may matter once we start doing skeletal mesh animation, where now, parent-child relationship matters because parent-child relationship is used to calculate the position of joints on the fly. However, I'm nowhere near there yet, and I don't really know what's going on. Animation, currently the way that I've got the render set up, the render has no concept of parent-child relationships, so animation like that may wind up happening in the engine. I honestly don't know. And my suspicion is I'm going to change things a lot because as I iterate and find out what different constraints need to be met, things will change. But for now, we're keeping the renderer simple, and the renderer just thinks of the scene as a bag of unordered meshes in 3D space. And so what's really important isn't the local positions, it's the derived positions. Problem is, it's not easy to talk about derived positions when you have a parent-child relationship. So let's say we only talk about global positions, and we just completely ignore the local positions. Let's say we've got a parent here and a child here. So we got a parent at 1010 and we got our child at 1315. And then let's say we move the parent to, negative 2317. And then we go look at the child. There's no way to easily recalculate what the child's global position would be. Basically what we have to do is every time we do anything to the parent, we then have to walk the entire parent-child hierarchy and immediately make those same changes. So in this case, we went from 10 to negative 23, which means minus 33, which brings us to minus 20, something like that. And this then went to 17, which would take this one to 22, if I'm even remotely capable of doing math, which oftentimes I'm not. And then if we make every time we make a change, we basically have to walk down the parent-child hierarchy, which is potentially expensive, potentially very inefficient, and anything that's expensive and inefficient, we want to optimize as much as possible, make as efficient as possible. The one advantage that this does have is that as soon as you make any change to the scene graph, the change is immediately propagated to all parent-child nodes. And that's very important because there are more efficient alternatives, which I will get to in a second, that don't immediately propagate the changes, and that becomes annoying. Because let's say, I change the parent's position from, negative 23 to 67, 4, and then if the changes didn't immediately propagate and I went to check the child's positions and they still hadn't updated, things would get confusing because if I go ask the child for its position and its position is wrong, or it gives me an old value, my game code might be wrong. It might do any kind of weird stuff that I'm not expecting. However, that immediate propagation updating the scene graph is slow. The other alternative is everybody keeps their local position. So the parent keeps its local, the child keeps its local of, 3, 5 or whatever. And we can change the parent like 4 times in a row. We can just keep moving the parent around. Let's assume that each time I change that represents like a discrete time of some piece of code within the game code touching the parent. Once all those changes have been made, at the end of the frame, we can go through and recalculate the child position. So we know parent's local, we know the child's local, so then we can derive the child's global one to be 816. Now this is much easier and potentially much more efficient for various reasons. One, we don't have to traverse the hierarchy every time we modify a parent transform. If a parent has children, we still just modify that parent, and then children can basically be ignored. And if nobody ever tries to access the child's position, the child's global position, we don't have to worry about the child's position being out of date. And we can just lazily recalculate the child's position before rendering occurs, just to make sure that the child's position is up to date. when rendering happens. This also lends us to a lot of efficiency. This gets back to that optimization that I was talking about that I was trying to do with transform data. If we have a bunch of transforms here, and then we've got a bunch of child transforms that point up to those parent transforms. What we can do as an optimization, if we're able to do recalculate derived positions all at once, is we can iterate over all of the parent transforms, recalculate their world positions if they need to be recalculated. And then we can iterate over all of the child transforms, and we don't have to check and worry about if the parent has been updated or not, because we know we've already updated all of the parents. So the child doesn't have to go like, hey parent, have you been updated? If not, make sure you update yourself, then update me. We can just do child, recalculate yourself relative to what the parent's current position is. And that allows for some really optimized code that can run really fast, especially over large scene graphs. But I mean, that in turn presents a number of implementation challenges. I think eventually that's the point I would like to get to, because I would like to be able to support large scene graphs in the most efficient way possible. Oh, and the other thing is this lends itself really well to parallel execution, because if we update all the parents and we know then all of these children can be updated in parallel. There's no dependencies between children, and all the dependencies to the parents have been satisfied. So if there are 1,000 of these, we can split those up among a number of worker threads and get them all running in parallel. And so, considering that I want to go for a highly multi-threaded engine, that seems like an ideal implementation. Whereas in the version where we have to recalculate the child transform or all the child nodes every time the parent changes, that might also lend itself to multi-threading, but it does present a number of challenges. So for example, if one worker thread is modifying the parent transform, only that worker thread needs to be updating any of the child transforms, and other threads can be doing stuff in parallel. But let's say one of the other threads is accessing one of the child transforms. Now we have potential issues with shared mutable state that we have to worry about, and potential, having multiple threads serialize around another one. And this could, the most pathological case for this could be there's one root transform at the top of the scene graph, and all the other ones are accessing it. And one thread modifies the root transform, and all the other threads are trying to look at child transforms, and now suddenly all the threads have to synchronize, and slows down the entire engine. If at all possible, I'd like to be able to avoid that case. I don't know. I've never really tried to implement anything like this. It's like I've barely tried to implement this in a single-threaded context. I've never done anything like this in a multi-threaded context. So there's a lot of questions that I still need to answer. So on top of, and so there's this one right here, this matrix derived. This is what we actually care about for rendering. So when we go to render it at the end of the frame, this is what the render is using. It's using this matrix derived. This used to be calculated by the engine and given to the renderer. This is actually now calculated by the renderer. What we're going to do now is when we calculate position derived, rotation derived, and scale derived, and then we actually give those to the renderer, and the renderer does its own matrix calculations, because it actually needs to calculate multiple matrices for those. It needs to calculate both world matrix and normal matrix, which I was previously doing some pretty nasty hacks to get that to work, and that was part of why I rewrote the renderer in the first place. So let's just talk about, so after worrying about local position and derived position, which are already a huge hassle, we still just have the question of parent can have children, a child can have a parent. So we might have multiple children and a child can only have one parent. I'm gonna make my cool ASCII art. Beautiful. So a parent can have children, and each node will have at most one parent, but root nodes will have no parents. I just love my ASCII diagrams. So a parent has, actually we could even flip this around. Where's my caret? So children refer to their parent, and the parent might have, a root node might have no parent at all. Any given parent could have multiple children, might have no children. And so previously, I've modeled this in what seemed like a pretty reasonable way. Parent is an option. It can either be one or none. Children is a vec. It could be 0 or more. Problem is ownership. I'm able to work around this. I was able to work around this in the old system with the ECS because I can refer to the parent and child entities. Entities under the old design conferred no ownership. So they're basically just unique IDs. So I referred to the parent's ID and the children's IDs. Under this new design, I don't currently have an equivalent to that. So let's say we did it this way. We did parent equals, we just directly had a graph of the parents. This is problematic because we'll note, let's say that we do have multiple parents and children like this. We have like some nested hierarchy. Oops. Both the parent and the child are going to have references to each other. There you go. Parent, our root is going to have a reference to its children. It's gonna own its child right here. But then parent also, under this design, owns its parent, or the child basically owns its parent, which it doesn't make sense in any language. But let's say we did this with pointers. If I were doing C++, this is what I would do, at least as my naive solution. Is each time I created a transform, I'd be basically doing like let parent, or this is C++, so transform star parent equals new transform star child equals new transform parent dot children dot push back, if this is a standard vec, child, oopsie, child dot parent equals parent. So if this were C++, this is what we'd be looking at. We do it with pointers. That way we can have, both the child, for example, let's take this node that has both a parent and children. The parent can have a pointer to this node. Root can have a pointer to middle, and children can each have a pointer back to middle. And it's fine because middle just lives on the stack. It's safe to have a bunch of pointers to it, no big deal. While that works in C++ and it would also work in Rust, and it's effectively what I've implemented here with transform data, it's where now instead of having ownership over it, we just have a bunch of pointers to it. There's a bunch of safety concerns. If for whatever reason we try to move transform data around in memory, which as we may discuss at some point, is important for optimization purposes, important for maintaining cache locality. So we do expect that the data is going to move around in memory. Pointers get invalidated, so that's already a problem. We have issues with ownership and lifetimes. If let's say middle gets destroyed, but root and child are still there, now we have dangling pointers. The solution works by doing it with pointers, but it's not safe. And I want safe. If I didn't want safe, I wouldn't be using Rust. Because as I learned in that issue that I had yesterday, safety isn't just about am I going to be hacked? Is somebody going to exploit a buffer overflow and hack my system? I'm making games. I'm not like making high security trading systems or whatever. So safety for me is more about avoiding bugs, making my code more robust. And so when I start doing stuff like this, just passing around raw pointers, I'm throwing away safety and basically inviting more of those more crazy disassembly debugging sessions like I was doing yesterday. And that's just not an efficient use of my time. I would much rather have bugs be caught by pointer checks or by, unwrapping an option that should never be none, or double borrowing a ref cell that should only ever be borrowed once. Things like that catch my errors at runtime. And if later on I need to convert that safe code to unsafe code in order to get more performance, I can do that. But starting out safe will allow me to have more, will allow me to catch bugs faster. I do not know. So here's what I'm thinking. So I know already that it's going to be tough to do. It's going to be tough to do something like this, where a parent, either the parent owns its child directly or the child owns its parent directly. The most viable version of this is a top-down version where each parent owns a list of its children. Or the other version is each child has an option box transform, because you can't do a recursive data structure like this in Rust anyway. So we could have each child have a pointer to its parents, like that. And then each transform node is allocated on the stack, and you can walk up, but you can't walk down. I think the more valuable version is we have to go parent-child. The parent has a reference to its children, because that's how we have to do our transform updates. We have to start at the root of our scene graph and then use the parent's data to update the children's data. And so when we do our rendering, we do our pre-rendering setup, we have to do a recursive walk down the scene graph. So this is how this would have to be implemented, but this is less than ideal. Like, I already know this is just a massive performance hazard. Doing this, like, every single element is allocated on the heap, and you have to walk down graphs and all that. So I think what I would like to do is and then this also has hazards for parallel access of elements, because we can't access elements in parallel. Yeah, I didn't even begin to talk about how this interacts with multi-threaded code. I'm gonna have to continue with this tomorrow. because there are, I still have to discuss doing a scene graph for a multi-threaded engine, which I don't have answers to currently. I'm gonna have to kind of break down the problem, take a look at what the use cases are, and what it needs to support. Interesting. I mean, I'm on an interesting problem now. That's exciting, but hard problems can also be frustrating because when you spend a lot of time thinking about the problem and not writing code, it can be disheartening. But I will try to stick with it. I'm going to ruminate on this overnight, see what I can come up with, and we'll pick up tomorrow. I think I'm gonna end the stream here because I'm not gonna make much more progress tonight. I gotta actually start getting ready for work. But thank you for watching. I'll try to pick up with this as soon as I can, and we'll see if we can actually make some progress with this sometime soon, because it's a very interesting problem, and I would like to put some work towards solving it. But I will see you all next time. I'm going to end the video recording now. So, see you on the next stream.